Large language models like ChatGPT, Anthropic Claude, or Google Bard are really powerful tools with lots of use cases. However, all these services have the same big drawback: privacy. What happens if we are dealing with sensitive data? We can't send that over the wire, even for reasons of compliance or even for reasons of trust. We can't really trust sending data over the wire, and we don't know what's going to happen to that. So this is where having a private language model we can run in our own machines is really valuable. There are literally hundreds of open source models that have already been trained and are ready to use. So join me in my quest to find a ChatGPT replacement I can run locally in my laptop. So before we start, let's set the expectatives. There are hundreds of thousands of open source models out there, some trained by individuals, and some like this, trained like corporations like Meta. To run some of these models, we need a beefy machine with lots of memory and even a GPU. Some smaller models can run on a laptop, but even with the best hardware, open source models are smaller in size and a little bit less powerful than polished products like ChatGPT. After all, OpenAI has dedicated hundreds of engineers to maintaining the thing. In this leaked document, it's called We Have No Mode, and neither does OpenAI, and it goes into great detail into explaining how open source has solved some problems like running language models on phones or multimodality. And here we have a comparison between closed and open source models. Open source models are quickly going over new iterations 1 or 2 weeks apart, and even they are smaller, they can do a very good job compared to closed source models that are maybe 1,000 times bigger. So you probably heard about the site HuggingFace.co. This is the largest repository for open source models. We can find projects and models that are uploaded by individuals or even by corporations. You can find models from Microsoft, from Meta, and here we have a lot of things. This is a really busy page because it's not only about language model but also about things like image generation, and really state of the art AI. But what we want for our use case for language models is to go here to models, and then we have to filter on here on the left side by tasks. So we have here a whole lot of tasks like audio or image processing. What we want is something along natural language processing, and I here this is the first thing we need to pay attention, because the kind of work we are needing depends on what task we choose here. So it's not the same to select translation than to select summarization. Ideally, we want to pick the best model for our job. In my case, for example, I would like to have something to chat with, so I will pick conversational, and this starts to filter. The other big filter here is in the library section, and this is all the kinds of libraries and ways of running the language models. Most of these models are transformers. Transformers is a type of model. This is the T in ChatGPT. And it's also a library from Hugging Face, a Python library that simplifies setting up a model. We also have popular libraries like PyTorch, TensorFlow, JAX, which is a Google library. Then we have some formats like gguf, which is a format used for Llama models, and Keras is another big library. So we're going to pick something here that we know how to use or we want to learn how to use. For starters, let's pick transformers, and then we can sort here on the right side for trending or most downloads, and open one of these models will give us information about the model. Let's pick one that I know it will work in my machine, because it's quite limited in memory. And for example, we can pick Microsoft Dialog GPT. This is a GPT-2 model, which is a smaller and older model, but here we have the model card, which basically explains how the model works, and more importantly, how to use it. So you have some snippets of code you can copy and paste on your computer and run the model. If you don't find any information here that's useful, you can always click here on use in transformers, and you will find a couple of snippets. Normally the first snippet is the one that starts your program, and this picks these models. The transformers library will download the model automatically in your machine and set it up, and obviously you need to complete the code with the logic you want to do in your library, in your project. So let's go and pick one of these. So to get started, we are going to need a few tools like a compiler, make or cmake. These are all things that I have installed in my machine, but you probably need to have installed so the library is compiled. We are going to start by installing PyTorch and TensorFlow, which will cover most of the things we are going to need for this example. We can use pip to install both libraries, and then we're going to install Transformers Sentence Piece. This is a version of Transformers that has the complete package, all the tools you will need to run Hugging Face Transformers. So let's create a new file, chat.py, and we are going to paste the code here. This is the code in the model. We are using this model, and this is the exact code that we find in the model card. The first time this runs is going to download the model, which in this case is about 3 gigabytes. I already ran it, so it's going to just start, but you're going to see that there's a little bit of a boot up time before we get the model to run. This is a small model, GPT-2, really medium size. So here we have a prompt. How you doing? And we should get some response. We have a warning here. I'm doing well. How about you? So this is basically the model is running using Python, TensorFlow, and the transformer library from Hugging Face. As you can see, to use this, you really need to code the behavior, because Hugging Face only provides the part that deals with the model, how to start, how to encode and decode the data, but the behavior of the model, of the application, you need to code it, you need to develop it in your application. So regarding Hugging Face Transformers, we can find the pros is that it handles the model downloading automatically, and we have snippets in the Hugging Face side to use the models. It's the best thing we have for experimenting and learning about machine learning, and of course you can integrate the code into your own product. For the cons, you do need a solid understanding of machine learning and natural language processing. This is something you will need to learn to use these libraries efficiently, and you need to code the application, the behavior, the logic, everything. It's on your side to do. You need also to know how models are configured for best performance, and it's not as fast as other alternatives we'll see a little bit later, so you really need a powerful machine to run them locally. So LangChain is a framework for building language applications on top of your models. It's an ecosystem that comprises connections to models. They can be local or remote, and all kinds of middleware to augment your application. It supports vector databases and all kinds of templating to create an application with Python that uses a language model as an engine. If we go, for example, here to components, we will find all the large language models that are supported by LangChain. We can even use a model from Hugging Face. We have integrations with Llama and all kind of tools. We can even integrate with OpenAI. This is not what we want, because we want something that runs on our hardware. So if you want to run the model with LangChain, you will still need the Transformers library and PyTorch or TensorFlow, depending on the model. You also will need to install Hugging Face Hub. This is a tool that's useful for managing models. And of course, we will have to install LangChain itself. So now let's create the same version we did with Transformers, but this time we're going to use LangChain chat. We are going to paste the code here. We are using the Hugging Face pipeline. This is part of the LangChain project, and we are using the pipeline from Hugging Face, the same model of before, Dialog-GPT medium. And then we have the prompts. This is all in the documentation, but basically we are using what you already have from Hugging Face Transformers, and we are supplying here a question. So let's see if it works. This is not a chat, it's just going to reply to my question, which is what is encephalography. So after about 10 or 20 seconds, we have the answer and it's working. So we can use this to build our chat application. So LangChain successfully accessed the model from Hugging Face, and that means it's working. And this is the start. Obviously, we can use a lot of more tools that LangChain provides to build a very complex application with lots of features, but this is the basis for running a model on LangChain. So going over LangChain, we can sum up the cons and the pros in one list. The pros is that it's easy to use because it has an ecosystem. You can run local and remote models side to side. And while you need to be a developer, you don't need to be a machine learning specialist like with Transformers. So you can focus on the logic of the application, but you still need to develop the application. The cons is the same as Transformers because it's slow compared to other alternatives. We'll see later. It's still running on Python, so you still need a good machine to run a model locally. So the third way of running a local LLM is with Llama.cpp. This is support of Llama models from Facebook's and Meta that run on C and C++. And we are going to see that they are most performant. They run bigger models on smaller hardware. I'm able to run a bigger model in this laptop, something that I couldn't do with Hugging Face, for example, or LangChain. So here we have basically a very optimized version of a model, and they have very a good support for Apple Silicon. So this is ideal, at least for me and for everyone that's using M1 or M2 chips. So it's a good way of running a local LLM using less resources. Okay, to use Llama.cpp, we are going to need to basically clone the repository. We're going to clone the repository. Once cloned, we can build the project with make. So now we can execute main, and we see that it's not running because we don't have a model. The Llama.cpp uses a special format that's designed for this project, that's GGUF. This is one way of storing the model formats. It's one of the most modern ways of storing a model compared with, for example, PyTorch or TensorFlow that uses .bin or .h5. This format is it's better, So we are going to go to Hugging Face. I'll locate one of the models in this format, download it, and then test Llama.cpp. So back to Hugging Face, let's pick a Llama2 file. There's a few. If you want the official Llama files from Meta, you need to create an account on Hugging Face, and the email must match the one you have in Facebook, and you need to request access, and that takes a couple of days. But if we don't want to do that, there's also a few models out there uploaded by individuals. We can pick, for example, this one, Llama2, 7 billion parameters, and it's in GGUF. You can see here in files and version the model files. There's different types of models. The Q comes from quantization, so it depends on how many bits the model uses. We can download for testing the smallest quantization model, and it will take a while, but once we have that, we can execute it on our Llama.cpp. Okay, so now that I have the model downloaded, I can use -m and call that. I have it in my temp file, and it's going to start. And since I didn't ask anything, I didn't put any prompt, it just start spouting random text. So let me cancel it. Okay, and let's start again. And now we're going to use the -p parameter, and this is going to initialize with some prompt, and we should hopefully start getting some information. So there's a lot of more options here. We can create a template, which would be the best, to interact with Llama.cpp, but it seems that it's generating some output. So let's see what we get. So we got an answer here. For reference, this is a model that wouldn't run with PyTorch or TensorFlow. So Llama.cpp is really more performant. We get at the end some benchmark about time, and so it's very interesting, and it allows me to run things that I would normally be able to do. Going over to Llama.cpp. The pros is that it's a lot more performant. You see that we can run models I couldn't have run with Python, thanks to being pure C, and it has a lot of optimizations. I can run bigger models with less hardware. I can run them in the command line or as a browser application, and there's a good number of options to tweak the behavior of the models. And if you want to build an application, you can still do that because it has bindings for various languages, so you can have your logic in, for example, JavaScript and Node.js, and the model actually be running with Llama.cpp. For the cons, is that it doesn't support all models in Hugging Face, only Llamafile models or Vicuña. There's a subset of models that are supported. You have to build the tool, so you need some knowledge and tools installed, and it's not as user friendly as some tools we'll see later on. So while we're talking about Llama.cpp, this is another project that's related from Mozilla. It's called Llamafile or Llamafile, and basically this is one portable script you can run anywhere. You can run it on Linux, Mac OS, or even Windows, and basically you can download this file and download a model and run it without having to compile anything. And you can even embed the model in an executable file that runs anywhere. So you can share your models easily and other people can run them just by double clicking on the file, which is great. So to use this project, we have a few options. We can download the file directly and it will just work. But since I already have a model downloaded, I don't want to download it again. I can just go here and use the project with external weights. So I will download the Mac OS version. I'm going to download the file. This works both on Mac OS and Linux, and there's a separate one for Windows. We need also to make it, let me see, executable, and running it will throw an error because we don't have a model. It's looking for the wrong model, but we can always put the -m and supply the model we already have from the last example, and it's going to load it. In this case, it's not a command line application. It will open a browser where we can interact with the model. So this is the starting page. As you can see, this is just llama.cpp, and we have a few options here to tweak the model. But let's simply talk to the model and see what happens. So it's starting to produce text. Let's ask the same thing we asked before, and we should, since the model is the same, it should provide a very similar answer. So here the model is working more or less at the same speed. But in this case, we didn't have to build or clone any repository, just download one file and one model. And you can see the answer is shorter because the options we supplied when we started the model. We also have the option to upload images and ask the model about the images. When the model is multimodal, in this case, it should work. So this is, I think, an easier alternative to running Llama.cpp. You have the same benefits, but with an easier install. So going over Llamafile, we can sum up the pros and cons in one list. The pros is the same as Llama.cpp. It's fast, and you can run big models on a small machine. And the other advantage is that you can build a single executable file you can share with other developers to publish, and it will run on any machine. The cons is the same as Llama.cpp because you don't have all the models available for you, only the models available for Llama.cpp. And there's yet another Llama version here. It's Ollama.ai. This site will give you an executable file for Linux or Mac OS. And once you download this and install it in your machine, it installs a command line tool and downloads the Llamafile, the Llama model, directly. So I think this is the easiest way to run a Llamafile because you don't have to. You just double click and then run your query on the terminal. Let's see how it works. So with Ollama, we have to download the tool and install it, and then pick one of these models that are here. For example, Llama2. We can, once we install it, we can go to the to a terminal. So once we install Ollama, we have a service on the taskbar, and then a command on the command line. And the first thing we need is to pull a model. We saw that we have a Llama2 model available. So this is the first step, to pull the model. And next we run Ollama run and the model name, and it should start a command line session. We can talk with the model here. Let's ask the model the same thing we asked so far to see if we have a good answer. So we have a pretty similar answer. It's a little bit slower than Llama.cpp or Llamafile, but it's really easy to get the installation going and to download models. Now with Ollama, I think this is the easiest to install and use way to run a Llama model. It's just double clicking and it installs a service on your machine, and then you open a terminal and just run, select your model and run your prompts and get results. Maybe you can run Llama Vicuña models very easily and it runs really fast. For the cons is you do have a limited set of models. There's less models than on Llama.cpp currently. Maybe that changes in the future. The other thing is that you can't manage the models. The tool manages downloading the models. So if you already have models downloaded, maybe you need to download them again. There's not a lot of options to tweak. This is really a tool dedicated to a user that isn't interested in using the language model, not in tweaking the things and the options. And there is no Windows version, so if you're on Windows, this won't work for you. So the last product we're going to see today is GPT for All. This is the most user-friendly interface because it includes a GUI, and it allows you to simply install the application, select one model, it automatically downloads it, and you can run your queries. You can even add your own documents into the application, and it will go and index them. And once you have the documents indexed, you can query them, you can talk to your documents, you can ask the model to summarize or translate. So this is a really good way of working with documents locally without sending them over the wire, and keeping them private and safe. So to get started, we need to download the installer for our system. So once we install the application and start it, we get this window very similar to ChatGPT. The first thing is to go here and go to downloads and select one of the models. Here you will find the available models, and we can select one of these. And I already installed Mistral OpenOrca, but I could not download any others. We have the sizes, and we can also interact with OpenAI with the API key. But let's use this model that I already downloaded. Another thing that's useful here is to go to the options here, and here we can change the prompt for the model, temperature, and all the parameters to tweak it. And one thing that this application has is that you can add a path, a folder. For example, I use my document folder here, and it will index that. And once it's indexed, I can simply go here and enable this folder, and now the model has access to all my files in that directory. For example, this directory has a lot of books on CI/CD, and we can ask, for example, that the model to give us a definition, depending on the files it finds in my docs, in my ebooks directory. So as you can see, we have an answer here, and it even provides the context. It identifies the book and summarized a definition from my documents. So it's really a powerful feature. Of course, we can use the model normally, like any other model, ask questions and everything, but with documents, we have more alternatives. So for GPT for all, the pros is that it has a polished GUI. It's a user-friendly option with things today. We can use local and remote online models like OpenAI. It supports 30 billion parameter models easily in my machine, so it's performing great. And you can add your own documents for context, so you can keep your data safe in your machine. For the cons, I would say that there's a very limited amount of models, and some of the models are not able to be used commercially. So the choice of how to run a large language model will depend on your needs. If you want ChatGPT, you can use GPT for all, which is one of the best ones around. But if you want to build a project on top of a language model, you will need something like Llama.cpp or even Python. If your goal is learning machine learning, you need to learn Python and use the libraries for machine learning. So I hope I made a case for running your own large language model. The models are only getting better, and I think the gap between closed and open source models are getting shorter and smaller all the time. And especially there's a case for using local language models because you are in total control of your own data. That's all for now. I really do want to explore AI in more detail in the future, so if you have any request, feel free to leave a comment. If you like this video, please leave us a like and subscribe so you don't miss the next one. Thank you for watching and have a nice one.